All right, so problem 17. We have this block and we want to know its acceleration at 2 seconds. So I know the force on it at 2 seconds is 4 newtons. So the acceleration is going to be the force divided by the mass, which ends up being 4/3 meters per second squared. Now, we want to know the speed of the block at 2 seconds. So what we're going to do is this. We're going to go from the force. We're going to use that to get the acceleration. And then we're going to use that to get the speed by taking an antiderivative. So let's go ahead and do that. So I know that the force is given by the equation 2t. I get that simply by looking at the graph and doing some algebra. I just kind of eyeballed it. I go over 1 up 2 over 1 up 2. So the slope is 2, so f equals 2t. And since I start at rest, I know the y-intercept is going to be 0. Now, to get the acceleration, I'm going to divide by mass. So that's going to give me 2/3 t for my acceleration. And so let's go ahead and take the antiderivative to get the speed. So that's going to be v equals 2/3 t squared over 2. Those cancel, and I want to put in 2 seconds here. So I'm going to end up getting 4/3 meters per second when I plug in the numbers. All right, now, question 19. This is actually very much like a problem we did earlier. But now we're going to have big M and little m. So let's figure this out. So I'm going to have tension and big mg here, and for the little mass, tension and little mg there. So I'm going to end up getting mg minus t equals big M times A. My sign convention goes this way. And then for the little m, I'm going to end up getting t minus mg equals little ma. And I want to know the tension in the rope. So let me go ahead and actually see if I can isolate that. When I do that, I'll work down here. I'm going to get mg minus t over big M equals t minus mg over little m. Let's multiply both sides by big M and little m. That's going to give me m big mg minus little m times t equals big M times t minus big M little m times g. So I'm going to end up getting 2 big M little mg over big M plus little m equals the tension when you actually do that algebra, which I absolutely expect you to do on your own. So that choice is going to be C. Now, I've got a projectile launched at speed v0 and an angle theta. And I want to know how long it's going to be in the air. So let's just remember v equals negative gt plus v0. This is to get half the time. And since at the top, the speed's 0, and negative gt plus, well, I forgot the sine theta. So it's v0 sine theta here. And so when I isolate, half the hang time is v0 sine theta over g. That means the total hang time is going to be double that, which is going to be choice E. So that's it for the multiple choice, and in the next set of videos, I'll do the free response.